The second thing we're going to do in this section is talk about radians and being able to convert between degrees and radians. So we know that measurements can be done in degrees, but angles can also be measured in units that are based on the arc length. 1 radian is the measure of an angle theta in standard position with a terminal side that intercepts the arc with the same length as the radius of the circle. So, on your calculator, you remember I told you had to set it up in degrees. Well, with this, you need to be able to set it up into radians. So again, ask me personally or send an email if you need help setting up your particular calculator into radians. Now, since the circumference of a circle can be considered to be 2 pi times r in this case standing for radius, 1 complete revolution of the circle equals 2 pi radians. Also, 1 complete revolution is 360 degrees. So that means 2 pi radians must equal 360. Or more commonly, pi radians is 180 degrees. So radians are oftentimes measured in terms of pi. So until you get used to radians and the angles measured in radians, it's probably going to be useful for you to convert your radians to degrees and in some cases convert your degrees to radians. So to convert from degrees to radians, multiply the number of degrees by pi radians over 180. I'm going to paraphrase that a little bit. So to convert from degrees to radians, take the number of degrees times pi divided by 180, like this. Number of degrees times pi divided by 180. Now you're not actually going to put 180 in for pi or 3.14 in for pi or any measurement for pi. Your answer is going to have pi in it. So it'll be degrees times pi, leave the pi in the problem, divided by 180, and then there's probably going to be some simplifying of a fraction. And then the other way, if we need to convert from radians to degrees, multiply the number of radians by 180 divided by pi radians. Now, the easiest way to paraphrase that is remember that pi is equivalent to 180 degrees. So if you're trying to convert from radians to degrees, replace the pi with 180 and then simplify. So example 4, rewrite the degree measure in radians and the radian measure in degrees. So we have a negative 30 degree angle, so we must need to rewrite that into radians. So follow our formula that's up above. We'll take the number of degrees, which is negative 30, times pi divided by 180. So initially it would look like negative 30 pi over 180. And then we need to simplify negative 30 over 180, those being the only integers in the problem. Pi is not an integer. Negative 30 over 180 would simplify to negative 1/6. So I could write that as negative 1 pi over 6. Or since I don't really need the negative 1, I can rewrite that as negative pi over 6. So that's what it is in radians, negative pi over 6. Part B has 5 pi over 2. So we must need to convert that to degrees. Well, pi is equivalent to 180 degrees. So we would take 5 times 180 and divide that by 2. I'm replacing the pi with 180. 5 times 180 is 900 over 2, which means 5 pi over 2 is 450 degrees. Down here, the diagram shows equivalent degrees and radian measures for special angles. You do not need to memorize that whole circle. You don't have to tell me tomorrow that 330 degrees is pi over 6. I'm not going to ask you anything like that. But what you do need to know is some of the more simpler ones. So they want you to memorize this down here, this part. 30 degrees is pi over 6. That is something that is commonly used, so it's easy to remember that one. It will help you out later on. So since pi is equal to 180, 180 divided by 6 is 30. We can say 30 degrees is pi radians over 6. 45 degrees is pi over 4. 60 degrees is pi over 3. 90 degrees is pi over 2. And remember, why this works is because pi is equivalent to 180 degrees. So that's another one that should be memorized as well. Pi is 180. A central angle of a circle is an angle with a vertex at the center of the circle. If you know the measure of the central angle and the radius of the circle, you can find the length of the arc that is intercepted by the angle. So a central angle has the center of the vertex right at the center of the circle. And if you have an angle with a vertex at the center of the circle, the angle is going to intersect part of the circle, and the part that's inside of the angle, the part of the circle, is called the intercepted arc. The important part about that is that we can now find the measure of not just the circumference of entire circles, but we can do arc lengths. We can find just part of the measure of a circle in cases that we need to know that measure. Formula for that is the length of the arc measured is S, and I'm not sure why it's actually S. So the arc length is going to equal the radius, that's what R is, times angle theta. Theta is in radians. Theta is in radians. So don't try to use this formula when theta is in degrees. You need to have it in radians, then you can use the formula to find arc length. So real world example 5, a monster truck tire has a radius of 33 inches. How far does a monster truck travel in feet after just 3/4 of a tire rotation? Okay, so in radians, how far is 3/4 of a tire rotation? When you think about that in degrees, 3/4 of a rotation would be this far. So how far is that? Well, that would be 90, then 180, and then 270. So that is 270 degrees in 3/4 of a tire rotation. So I do need to change that degree measure into radians. So that's 270 degrees. So 270 pi over 180 gives me 3 pi over 2. So that's 3 pi over 2 radians. That's the measure of the angle. So now I can use the formula for finding arc measure, which is going to be the radius. In this case, it's 33 inches, times the measure of the intercepted angle, 3 pi over 2. And that's going to equal 99 pi over 2. So the tire actually moves 99 pi over 2 inches because everything was given to me in inches. Well, when was the last time you said somebody moved pi inches before? So let's go ahead and change this into a decimal estimate. So if I use 3.14 for pi, and I'm using 3.14 for pi now because now we're trying to figure out the arc length. We're not dealing with an angle measure, so pi is not 180 degrees. It is the length of something. So I'm going to use 3.14 for pi. So take 99 times 3.14, take that divided by 2, and you get 155.43. And that's in inches. But the problem says, how far does the monster truck travel in feet? So I need to convert 155.43 inches into feet. So I simply just need to divide that by 12 because there's 12 inches in a foot. And I get about a 12.95. If I want to round that to the next highest number, I could say it's approximately 13 feet. So 3/4 of a truck tire rotation in this case, the truck moves 13 feet. A circle has a diameter of 9 inches. Find the arc length if the central angle is 60 degrees, round to the nearest tenth. Okay, so yet again, we can use the formula for arc length. Arc length is going to be the radius times theta. But theta has to be in radians, so I need to convert 60 degrees to radians, so that would be 60 pi over 180. 60 over 180 is 1/3, so this is the same as pi over 3. So I'll replace the theta with pi over 3. And then I also need the radius. Now the information they give us here is that the diameter is 9 centimeters. Well, I need the radius. Well, remember the diameter, or the radius, is half the diameter. So if I just take 9 divided by 2, that will give me the radius. Radius is going to be 4.5. So the arc length is going to be 4.5 times pi over 3. So that could be 4.5 times pi over 3. And 4.5 divided by 3 is 1.5, so I could write that as 1.5 pi. Then it says to convert that and round it to the nearest tenth. So since now I'm dealing with length, I'm going to take 1.5 times 3.14. That's 1.5 times 3.14. And when you take 1.5 times 3.14, or you can use the pi button in your calculator, rounded to the nearest tenth is approximately equal to 4.7. And again, that is in centimeters in this case.